Okay, guys, welcome. This is going to be the first of hopefully many live streams. I'm going to be doing these every Saturday at the same time, so at 1 p.m., and it'll be on Discord. Anything that anyone who misses this, I'll try to upload this on a YouTube channel that I will try to make sometime today. And other than that, I'll also upload the videos onto my website. For those of you who don't know the website, it's gonna be okay. Uh, Anything and everything that's done inside that I do within my practices, that I do with the course, all the information, that is gonna be up on this website. If you have any like problems with uh, stuff, you can also just email me. My contact info is there. So we're just going to, let's see, someone says they have problem with hearing. If you have a problem with hearing, there's a setting somewhere in Discord. I guess it depends on whatever computer, laptop, phone, or what tablet you're listening to, but you're gonna have to change that setting so that it works for whatever device you're listening watching on. I that's a very Discordy thing. Yeah. Okay. Well, there you go. That's fixed. Okay. So, this is gonna be today. I'm gonna focus on like the beginnings of functional because we have some people. I don't know if they're here, but I have some people who, uh, they're new to the class. They didn't catch the first couple lectures and practices, and also there's some people who may have gone to every practice and lecture, but still just don't get it. So that's fine. That's what these additional streams and practices are for. Okay. As I said before, if you have any questions, you can try to talk to me on the mic. Just let me know so that we don't talk over each other, or you can just type into the consultation stream chat channel so I can see that. I have that one open. So if you type in general, it might take a little longer for me to actually check your message. So yeah. Uh, so yeah, the idea of this stream is that it should like yeah, I'm gonna sort of lecture you guys, but at the same time, it's not just a lecture. Like the idea is that you can see what I'm typing, and at the same time, it can be interactive. So if you have any questions or anything, you can just ask and see how I work through all of them. If something doesn't make sense, tell me to repeat, or maybe ask me to show you a different way. Maybe one method of showing you doesn't work. I'll try to find something else. Okay. Uh, so yeah, let's get started. Okay, so the program that we're working with, if those for those of you who don't know, is called Clean. So this is Clean IDE. It's the best game of the year. And Clean is one of many functional languages. So you guys can Google functional languages or search it up on Wikipedia or the many amazing resources that are online nowadays. But yeah, Clean is a functional language. And as a functional language, it has very certain specific aspects of it that will make it much better than imperative languages in some regards. But it also is why this class can be much harder for some people because some people they just think better in imperative, or they prefer that way, or they just started off that way. So for a lot of people, they're they like to think in imperative, so learning functional becomes an incredibly difficult thing. For others, maybe you just never had any programming experience. That's okay. And so maybe functional is just hard because you're just learning programming for the first time. Uh, in any case, I'm not going to go over how to install Clean, just because there's a whole website for that. It's on my website. You go to the website, you can download it. But another reason why I'm not going over how to install Clean is because you can do it on Windows one way, but it doesn't work for everyone that way. So then you have to run a different way. And if you're running a Mac or a Linux, then you have to do some extra stuff. So I would suggest coming to the actual in-person consultations on Tuesday so that myself or any of the tutors, we can address that problem. So like if you have a Mac, for example, like come to the consultation. We'll help you set it up and all that stuff, and maybe you can even figure out what we're actually doing. So I'm not gonna show you guys exactly how to set up Clean. I'm gonna assume you have Clean already installed. If not, you can also use the school computers, and they all have Clean, or they should all have Clean. All right. So first thing we're gonna do is we're gonna create a new file. So when you create a new file, you're gonna see here that says .icl. Can everyone see my screen and what it says? I know the font isn't the largest, but there's only so much I can do. Anyways, is there a full amount?
Is there a full amount?
Is there a limit to how many people
Is
can
there a
join this
limit to how
channel?
many people can join this channel?
No, there's no limit. There's no limit on this channel. That's weird. Okay. Anyways, so here we have a new window. You want to make sure that when you type in the file name that you actually type in something, and then you have this .icl extension. So a lot of problems that people have is they won't type in that .icl file. So they'll just type in something like this, and then when you open it, you'll get this, and it won't. They'll type in code and whatnot, and they try to run it, and they'll be like, professor, why is my code not running? And then we'll look at it and be like, well, your screen looks green and not yellow. That means that this is a text box. So literally, this is a text box, and there is no code here. So anything you write into there, Clean won't bother to think of it as code because it doesn't recognize this as a code file. So don't do that. So when you make a new file, call it something.icl, okay? Now, in order to start, is the stream lagging? Some people say the stream is lagging. Is there a lag for... Is there really a limit on the stream? I don't, to my knowledge, this doesn't have, there's no limit on the users, but let me try to lower the bit rate. Maybe that might help. So if I lower the bit rate, and then there's 10 viewers. What is there a limit of 10 viewers on this thing? Let me see. Stream has oh my god, I did not know that Discord had a max viewer count. That is actually weird. I should keep that in mind next time. Okay. So maybe I'll switch the streaming over to a different channel that doesn't have such a limit. I did not know that it had a limit. Or let me see if it's something in the server channels. I don't think it is, but let me see. Auto log. Let's see. Don't.
Let's get started.
Okay, I definitely don't. Okay, so I don't see a way to increase the number of people watching the stream, and I did not realize that somehow there was a limit to this, which seems a little kind of weird for... Okay, well, do you guys want to move to another place? I don't have Skype. I don't use Skype. Skype's been kind of dead for a while. Sorry guys. Twitch.tv. Yeah, I would need to set up a Twitch account. The reason why I did not want to do Twitch is because I know if the watchers, the guys who are watching, if you're not a Twitch paying member, you get ads, meaning that you'll be in the middle of watching me do a problem and then suddenly it gets cut off with an advertisement. That's the reason why I did not want to do Twitch. That's kind of the same reason why Facebook, on the other hand, I also don't want to do because it has a really bad interface. So only can hear my voice. Okay, so we're having some real technical problems with this. Why is there no like good? Google Hangouts could possibly work, but that's assuming everyone has a Google account. Do you guys all have a Google Hangout account? I don't even know about Google Hangouts. I never tried it, honestly. It's like a Google Hangouts like an app. But let me see if it's okay. Yeah.
뭐래? 뭐래? 어?
Okay, so
프로그래밍을そう、今ライブでやってるの。
okay, and forget you should probably mute your mic.
何が
Okay, anyways, so should I continue here or should I go on to Google? What do you guys think?
授業教えてる人がやってくれてるのよ。これ難しいから、もういっぱい開いてるの、コンサルテーションをこうやって。
Okay, that's me. Google Hangouts. Google Hangouts also has a limit up to 25, but it's a little bigger than this. Okay, in that case, I'm gonna say, I guess I'll. Alright, so what I'm gonna. Yeah, I think I'll just continue here and move it to YouTube, and I'll move certain user out so that someone can join in. Okay. I have no idea if YouTube puts ads. I don't think YouTube puts ads. That's why I was thinking about doing YouTube, but I don't have a YouTube channel. So I've only had a YouTube account. But I guess I can also do that. Yes, I've tried Facebook live streaming, but the quality is crap, and also it doesn't let me get the videos afterwards. So it's kind of a pain. Okay. Well, anyways, I'm gonna just continue here. Whatever. So, alright, sorry about that. So alright, we'll just continue here, and I guess I'll figure something out for next time. Alright, so when you have a file, an ICL file, whatever your file name is called. So here I called it Livestream 01. You have to start your file off with exactly that. So I'll call my Livestream 01. Okay, so if you call your file name something crazy, then if it's something crazy.icl, then it'll be something crazy here. Okay, don't type in the ICL, you just type in the file name minus the extension. This way Clean knows, okay, this is the file we're looking at. Then you want to do import and standard environment. This import statement is pretty much identical to how C++ operates, where you import the C standard library or something similar. So it basically says, oh, here's a whole bunch of standard functions and stuff that you can use to do a lot of stuff. And you can see all of this later on. I'll show you how to read the standard environment library. Okay. All right. So what are some basic things here? So this here is your code window. So if you're using the Clean IDE, your code window is gonna look like this pale yellow, and you're gonna have this project window that's gonna look like this brown. And then you have a couple other windows. You have a blue window that has some information. You have the very famous pink window, which you'll probably see a lot, which is the error window. And then you have some other ones. So get used to which window does what, because you'll need to know that. Another thing I tell people is go to defaults, window settings, editor settings. So here we have default, window settings, editor settings. So if you go to default window sign, editor sign like that, you can do defaults. You can change this. You can change some settings on here. Whenever it shows up here, you can change your font. You can change the size of it. Mine is currently at the largest. And then you can. But one thing that I would say, do this show line numbers. That's probably the most important thing, because then now you can see if you have an error and it tells you it's on line 1, 2, 3, 4. You don't have to count 1, 2, 3, 4. You can just go down to that specific line. Okay. Alright. So from here, let's start with our basic thing. So if you want a hello world in clean, this is probably the simplest hello world we can do. So I'm going to type start equals hello world. And then from here, you have to do file, new project. So you have to create a new project. You see I have a file that has livestream01.icl. I'm going to have this, it's called livestream01.prj. Leave the name to be identical to the ICL file. It won't, it'll be okay, but keep it in the same folder. Okay. And then you create the project. How do you know you've created a project? When you go here, you have this puke brown window and it'll say project livestream01.exe. So this is the executable file. And then it'll say livestream01, that's your project name, and this is like the list of things you've added to it. So we know we have our module in here. So when you see this, you know your project's been made correctly. If it doesn't look like this, well, then you probably should just make a new project. Okay, so from here, we can create a new project, and then if we go project, bring up to date, just updates the project, bring update and run, saves it, updates it, and then runs your code. So usually that's the one you want to do. Control R, update and run, or you can just hit this little button right here. So say update and run. Okay, most people go for the button. I use Control R, doesn't matter. So from there, let's see. I don't think you guys can see. Can you guys see the output? No, you guys can't see the output. That's actually kind of inconvenient. Okay, well anyways, there's an output. This, if you guys try this on your window, it'll output hello world just onto your screen. So this is the most basic hello world. What this is saying is we have start is equal to hello world, which is a string. So on your console, it'll just put out hello world because it's like, hey, oh, you want us to give you this string hello world. Here is hello world onto your screen. Now, one thing to keep in mind for functional programs is that they all start from here. So they, I'm gonna put this in comments. The program starts from the start. So program starts from start. So this is kind of, I don't know, seems kind of obvious, but I don't know. Someone has a question. If you have a question, you could just type it in. You don't actually have to say, I have a question. You could just type in the question.
So I try to put new project, but it says like no
chơi
more.
gì vậy? Chơi đánh cờ thì đó là lỡ lời đấy không chơi. Tôi đã có chơi nghỉ lâu lắm.
Okay, people have got mic. If you guys have problem with people with mics, you can right click on their name and mute them. So for those of you new to
chúng nó nói thì sao?
new to Discord, you can right click on someone's name and mute them manually on your own. For those of you, okay, so this guy, he's saying he can't create a new project because it says no active module. So what that means is that you have to actually click into the module. So if I'm gonna, how do I close? Let me see. I'm just gonna close this. Yeah, yes, sure. I'm gonna close this. I'm gonna close the project. Alright, so let's say I open my ICL file and I want to create a new project, but I have a different window open. So this is this is one window and this is a separate window. Okay, let's click onto this error and warning window. So let's say this is my active window and I try to create a new project. It's gonna give you this pop-up, no active module window. And the idea is that you can have a lot of things open and you need to click into your module. So click into this file, click into this window, and then create a new project. that way it knows, oh, this is the one you want to associate the project with. So I hope that answers your question about no active module. Okay, all right, cool. Now, so where were we? So functional programs all have generally some sort of start statement where your program starts, and then after that, you can write a bunch of stuff. So functional is very, well, how to say, very mathematic. So if I say start equals 2 plus 3, this is going to output onto our screen of 5. Okay? So we can think of the start as a starting point, or if you like to think, you know, if this helps you think of it, this is like saying y equals 2 plus 3. So we're like, well, what do we want our y to be? Well, our y is going to be, well, 2 plus 3, which is 5. So when you do any function, one nice way to help you get into the whole functional way of thinking is that everything is math and everything is a function similar to how it operates in math. Now, there are some differences because this is programming, but everything here is a function by the higher math definition. And so everything matches that definition, meaning that there are certain things like functions only functions always will have the identical outputs or stuff. So let's see what this means. So let's say in math, you'll have something like, you'll probably see this like, oh, I have f of x is equal to x plus 2. So this is just a function where if we took f of, say, 3, well, what happens here? Well, x now becomes 3, and we get 3 plus 2, which I hope you guys know evaluates to 5. So that should hopefully be straightforward to you guys. Okay, so then afterwards, we can define this exactly in clean. So how it says here, f of x is equal to x plus 2. We can write this as f of x equals x plus 2. So that's the clean notation. So we have a function in math which we just add 2 to x. This is the clean equivalent. Okay? So and let's say we have f of 3 here. So let's say we define f of x. Then in that case, if we do start equals f of 3, this is almost the same as saying our y is equal to f of 3, f of 3, like this, okay? In math. So then this f of 3 will be evaluated to, it'll be pattern matched. So it'll try to match into something. So here we have f, and then we have one argument, okay? The clean is going to look for f and one argument. So it's going to look for something that matches this name f and a one argument. And it's going to see, oh, hey, we have x plus 2. So it's going to basically do so what I'm doing here, which is a copy paste. I'm just going to be like, okay, boop, put that there. And then it's going to say, what's x? Well, x is 3. And then here it's going to say, well, now we're done. We could give them a 5 back, which is exactly how you would sort of evaluate all of this in math anyways. Like that. Okay. Any questions so far? If you guys have any questions regarding this, just let me know, or stop me, or pause me. And if I don't hear you on mic, because maybe your mic was on and I had to mute you so that my brains don't get blown out, just type in chat, please. Yeah, some of you are still going to be muted because your mic is perpetually on. All right, so let's see what's next. So additionally, you don't have to, you can have multiple functions. So we're gonna say, let's say we have a different function in math. We can have a g of y, g of a. Let's say g of a, and g of a does 3 times x. So this function multiplies x by 3. So if we stick in g of, say, 2, this will give g of a, sorry. This would be 3 times 2, because a is now 2. So for one, the a here is going to be replaced by 2. So first off, you can call your argument anything. It does not have to just be it doesn't have to just be X. It can be A. It can be, in fact, in clean or and in many functional languages, you can call this some crazy name. You can call it something really long. What's important is that wherever you call it, is that you keep it consistent. Okay. So then let's do. So then in this case, if we do in functional, this would be g of a is equal to 3 times a. Now in math, you can also do what's called nest. You can like compose functions, or if it makes more sense to you guys, you can nest functions. Although it's actually called compositional functions. So I can do g of f of x like this. Okay. So what would this mean? Well, this means that we can evaluate this from inside to outside, but let's go from outside inside. So we start with g. Okay. So what is our g? Our g is 3 times a. Now our a here is now not a anymore, it's f of x. So I'm just going to place it in here, f of x. Well, what is our f of x? Well, let's say x here, let's call this, let's give it a parameter. Let's give it 56, okay? So we'll call this 56. So our so if we just did g of f of 56 here, well, we can expand g out. We get 3 times f of the 56 just based on taking definition of this. But we're not done yet because we can't really figure out what this means. We don't know what this is equal to because we still have f of 56. So we're going to see what f of 56 is. In this case, f of x is x plus 2. So it's going to come out to this. I'm going to stick it in parentheses so that it's clear. But we know that x is 56 now. Now at this step, we can evaluate all of this, and this will give us some number. So we'll evaluate this inside, which is 58, and then time to do math. This will give us 150, 172, 174. Ah, there you go. So that's how it mathematically evaluates all of this. Yeah, there are people having trouble getting in. Yeah, next time I'm going to have to stick this on YouTube. Probably stream on YouTube. Seems like the best. Anyways, okay, so now we have g of f of 56. It'll give us 174. Now in clean, you can do exactly the same thing. So in clean, we can do g of, so we'll just do it this way, f of 56. So in this case, in clean, this means that we have a g function, and what are we feeding it? We're feeding it f of 56. So this will evaluate in exactly the same way. So we'll just say in this case, what is g of one argument? It's going to search for g plus one argument. It's going to say, oh, it's here, matches this. And then it's going to evaluate for a. So it's going to be like, well, what's a? Well, a is this thing here. So we're going to put that here. And then it's going to try to figure this out because we're not done yet. And this step and this stuff is called reduction. Okay, so this is what we're doing right now is called. So in this case, f of 56, it's going to search for f and one number, which is going to be x plus 2 over here. Okay. And then x is going to be replaced by 56. Yeah, I'm actually wondering if the people who can't. I wonder if they can hear me even if they can't see the video. Oh boy. What is this? I do not understand how this works now. Somehow the video, when I stream, goes to a voice channel, which I can't seem to. There's no limit on people, but the video itself seems to have a limit on people. I don't understand how this works. Yeah, I don't understand. Oh well. Oh, streams in Discord are still available. Maybe, I guess next time. I don't think Nitro helps with the stream number because I have Nitro because I actually use Discord a lot, but I don't know. Anyways, it's fine. Next, I'm going to upload this to YouTube. I guess now I have to make a YouTube channel, and then next time I'll stream on YouTube because I know YouTube doesn't have limits, and to my knowledge, does not have ads. But if it has ads, I guess we'll just have to suck it up. Or we can go to Twitch. But last thing I want is us getting randomly rated by a Fortnite streamer. That would not be cool. At least I know in YouTube I don't think you can raid people. So yeah, I don't think I want to be rated by a Fortnite streamer. Alright, so this is basically the basics of function comprehension in clean. So if we were to define a function in clean and use function comprehension, we could do something like, we could say g of a is equal to a times 2, while f of b will give us b plus 3, and then if I do start equals f of let's say g of f of g of f of 1, let's say that. So like that. So in this case, this is a whole bunch of nesting, and of course I don't have enough parentheses. 40. Yeah. So of course I don't have enough parentheses. This is 1, 2, 3. Nope, it's not that one. Yeah, missing one parentheses. So yeah, and this will evaluate into 25, but I'll show you guys the steps. Okay. So let's show you how this gets evaluated. So the way this evaluates is it's gonna start evaluating at start. So start is like your y. It's gonna say, what is our start? Well, start is this ugly thing here. So it's gonna say start is this. Well, what is this? So we can evaluate things from inside out or outside in. I find that generally for people who aren't used to how functional and thinking in functional works, it's sometimes better to evaluate from outside all the way to the inside. But if you can't do that, you can do inside to outside. This might get a little more messy. So like for example here, we have f of g of blah 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 blah. So we're gonna say f of one big argument. Well, we don't care that it's one. There's a lot of stuff. We just know that it's f and one argument. So we're gonna say, well, f of b here is b plus 3. So we're gonna say this should give us. I'm just gonna do it this way. It's gonna be b plus 3. Now, except the only thing is that we know that b is not b anymore. B is this crazy thing here. So we're gonna be like, oh, there's a bunch of stuff here. Okay. Now, in this case, we're gonna say we have our next step here, which because it can't evaluate, it's gonna be like, well, what are we adding to 3? We don't know. So now we have to go one step more. So it's gonna say, well, we have g of one argument here, one ugly argument here. So what's g of one ugly argument? It's a times 2. So we're gonna take this and replace it with a times 2. In which case, a is now this ugliness. So it's gonna be like here. Okay. So this is now the new function. Now we're gonna keep doing this, and because I decided to be a pain for myself, there's quite a few more steps, but basically it's the same thing. Whoops, did I just remove this? Okay. So then in this case, f of one function is b plus 3. So this is also gonna be b plus 3. So this is gonna be b plus 3, where b, so it's b plus 3, where b is this gf of 1, like that. And then from here, it's gonna keep going. So we're just gonna keep going for this. So this is how you start nesting a function. I'm gonna, whoops, my bad. it's going to go gf of 1. Well, gf of 1 is going to be a times 2, so we're going to have this f1 times 2. And then from here, finally, we'll evaluate for f1, which we know f1 is b plus 3, so that's 1 plus 3. 1 plus 3, okay? Now, there's one thing to keep in mind. You see how I left all these parentheses in? It actually kind of matters because this will dictate the order of how things are done. Now, in the case of addition and multiplication, it does not matter what the order is just because it's really addition and multiplication, so the order is not quite as important. But for things like division and subtraction, then it makes a huge difference because a minus b is not going to be the same as b minus a. Now after this, now it'll just collapse all this and evaluate it. So it'll collapse them level by level. This is 4 times 2, 8, plus 3 is 11, times 2 is 22, plus 3 is 25. So this will give us 25. Okay. So that's how you compose functions. Now there's one thing I want to point out about composition functions that even now some people are having a lot of trouble wrapping their heads around. When you throw an input into your function, one of the main things that people don't quite seem to understand is that when you input into a function, that input never changes. So you can have a variable and that variable won't change. So what do I mean by that? So here, this one here will count as our b. We could say that one is our b1. So here we'll say that b1 is equal to 1. Okay. Now we do that. Okay, actually this one was going in. So we can say that this is our b, which is our 1. Now when this gets evaluated, you can say that 1 plus 3 will give us 4. So 4 becomes the input into this g here. But so we can say a1 is equal to 4. Okay. Now the thing about that is then from here, this 4 gets fed into the g. Okay. So we're at 1 was b. Then 1 plus 3 gives us the 4 for a. Then a times 2, so 4 times 2 should give us an 8 to feed into the f. This is technically, even though it's called a b, it's a different b. This is b, you can call it b2, like a separate b. Okay? So what's important to keep in note is, what I'm trying to point out here is that even though we're reusing the same function, and you can think of this as almost being a recursive call, like we're repeating, well, in this case, 2 functions, but we're repeating the functions. So it's almost like a recursive call here. And each time we use b, we're not actually overwriting the old b at all. We're actually creating basically a new b. And you can and I'm just putting the underscore number just so you can kind of understand that there's a sort of, it's not the same b. So we have b2 here, which would then get thrown into a g. So we'll get thrown into f because it's b, right? So 8 plus 3 gives us 11. So we could say a2 is equal to 11. And this, because it's a, and we know that the next function will be a g, it'll get thrown into times 2. So we could say that 3 gives us 22, because then it gets fed into the b of the next f function, where there's an a3, which gives us the 25. So in this one, we're using a and b repeatedly. And this will be very, very important for recursion, in that, yes, we are using the same name. And what I'm trying to explain right now is actually not even just a functional thing. This is going to be similar in C++, Java, and other programming languages. When you have a recursive function, your parameter inside the function might have a name. So your parameter will have a function called a, and inside the function you'll do something to a. Okay, just like here we have b and we do something to b. But if you do a recursive call here, like this, we are using b over and over, but you're never actually changing the original b. And this is one of the main tenets of functional, is that the original, that your values, they're immutable, they don't change. So if you for some reason want to grab the original value b here, you can. It would never have changed. So when you're adding 1 to it, when you're multiplying by 2, and you're what you're doing is you're creating a new value that has that value. You're not changing the original value. And this is very important also for lists. So what's one thing to keep in mind? So for one sort of tricky thing that some people can't seem to handle when it that people have trouble to overcome is that when you're modifying something that's a data structure, so not something simple like a number, but something bigger like a list or a tree or whatever, is that when you change that list, when you remove an element, when you add an element, when you reverse it, same with a tree, if you decide to flip it, take out nodes, reorganize it, you've never what you've done is nothing to the original tree or list, and what you've done is created a new tree or list that has the new changes. So you're never actually changing something. And this is very important because some people will try to write a function where we say, okay, remove or do something to this list. And then they'll be like, why am I stuck on the first step? Or why am I only gaining the original output? And the reason for that is because you've never actually changed the original output. So let's say, I write the function. So I can write a function to show you guys how this works. Let's call this function 1, and it takes in an x, okay? So we'll say if I don't know, it's hard to think in terms of bad code, but let's say if it's even, we'll do x. We'll say some people just return x, or you get, so if you return x plus 2 here, let me just explain from good code, because trying to write it in bad code, it's kind of weird. But some people will try to they do it. So in this case, this one is even x equals x plus 2. So, or let's say is odd x equals x plus 3. Okay, so in this case, we have sort of an if then else statement going on here. But one thing to keep in mind is that when you feed in here and what you output here, these are different. So this is very different from, these are different variables. Now, why does this matter? So let's say I have f1 of 3. Let's say actually I say out here x equals 4, and then I say f function, let's call this something else just to be safe. Let's say it is. So let's say I say start equals function 1 of SA. One thing is that in this case, SA is going to be 4, and SA is not going to change. In fact, SA, if you ever call SA again, is going to also be 4. When it enters function 1, it's going to become this x for function 1, where it's going to be checked here. Okay, is it even? Is it odd? In this case, I put 4, so it's even. So then we should get an x plus 2 back. So what's important is remember that SA, as it is, won't change. Okay? So here, after we do all this, SA is still 4, but we have a value 6 that's returned by function 1. So what happens to this 6? Well, it doesn't have a name yet. So then what happens to that value? Well, in this case, it goes to start, meaning it goes to start and then gets output onto the console. Now, you don't have to output on the console. I can put in something here. So now LFEL, if I check the value on that, this will give me 6, because what it did was we did an operation on SA, but SA doesn't change, but the return value from that operation gets stored into LFEL, which then in this case we store into, you could say we give it to start, which means it will output a 6. Okay. I hope that makes sense to people. Alright, so from there, does anyone have any questions? I know unfortunately we don't have room for everyone, but I guess people can listen in I guess that can work. I know some people left already. Sad days. And does anyone have any questions? Okay. Is there anything that people specifically want me to cover? Otherwise, I'm going to start going into recursion and lists. Yeah, I figured the homework is something people would want. Only the slides of the lecture? What's wrong with the lecture? I don't know. The lecture, okay, the lecture, if you have questions about what's on the lecture slides, well, first thing I would suggest, please go to lecture. So if you're going to ask questions about the lecture and you didn't go to lecture, go to lecture. It's basically a solution to that. Now, if you have questions about stuff that's on the lecture slide, actually the best is generally to actually ask during the lecture, just because, in all honesty, Victoria knows way more about functional programming than I do. So, yeah. But, just, let's see, what's that? Oh, the infix. Don't worry about infix right now. But the thing about the lecture slides, if you don't understand something from the lecture slides, most of it's theory, and if it's the practice stuff, yeah, I guess I can go over that. But the infix, when do you define functions like that? Not yet. So Mojito is asking, when do we define a function like infix for : I'm just gonna copy this to screen. So the question was this. So the question was infix for blah a, list of a goes to bool, blah less than equals a, whatever, like this. And I think that might be copied wrong. Oh no, that's fine. Okay, so the question is, when do we have to define something like this? You don't do that yet. This is something that you define when you define your own type. So you will do that, but later in the class. But that's the second half of the course, and actually, if I'm not incorrect, this is closer to the end of the course. So for now, you don't have to worry about that. What you need to understand is what it's saying. What it's saying is that we have two lists of a type. So we have two lists of a type, any type A, and the return should be a Boolean. And there's a condition. So given that less than or equal to is less than and equal are defined on A. So that's what this means. This means that, and I'll just type it here. This means we have two lists of type A, and the return result is of type Boolean, and the function requires that type A has equality and less than defined for it. Okay, so that's what that means. So you're going to see sometimes you can have, so like you might see something that's like A, B, and I don't know, C, D, like this gives you type E, something like that. Like, let's say you see something like that. What this means is that, actually, let me change one of these. So let's make that A. Okay, so what this means is that we need a list of type A, a single element of type B. This is a tuple of type where the first element is type C and the second element is type A, meaning it has to match this. And it will return last element, let's call it B actually, of type B that will match this one. Okay, so when you see these in your definition, in the implementation definitions or the declaration definitions, that's what they mean. They mean you have a type, and they just say generically like, okay, it's a type A, B, whatever, but you also know that certain ones of them have to match. Let's see, no and in bool function. So someone's asking the and function. So your logical operators do exist in clean, by all means. So your logical operators, I'm just going to type this out here. So your logical operators, this is and, this is your or. What else do we have? And or not. You have a not operator, not function, which basically does the negation. I believe it's not. Let me check that. Yeah, not. And if you guys ever get confused, you can also do what I just did, where you're like, oh, I forget. Well, you can just use this. So here we have, so how did I pull up that nice little pink screen? So you have one pink screen that says error and warnings, but that's not the one we want. The way we get that, and that will be very helpful in test, is you make a module name, you import an environment, and then what you do is you highlight something, not with a space. So if there's a space, it won't work. You can't do it like that. Just highlight just this, go to search, go to definition, and then you'll get a lovely pink file, which is of the DCL file, which will contain a lot of functions. So here we have to bool equals from bool, and in this case, logical operators not and or. I don't know which other ones you want. Oh, the guy was asking about greater than or smaller than. I don't believe there's greater than or smaller than, but we can check that. So how do we check that? I'm going to check in. Let's type in ABS. So this is how I would usually access standard overloaded. So standard overloaded has all these like number functions. So you can say what's less than, equal to, greater than, and I'm pretty sure less than and greater than isn't defined for booleans, but you can check that in the boolean definition somewhere. I wonder if there's a standard boolean we could look into, because there's a standard integer. So this is integer. So in standard integer, you can see that there's a plus addition defined, subtraction defined, there's a zero defined, division, 1, exponent, absolute value, sign, negative, equality, less than, is even, is odd. Yeah, this is integers, okay? So that's integers, but you can there's also going to be a file for booleans. Actually, I wonder if I can search that file up with true. Standard, no, that gives me standard class. I'm sure there's a boolean file somewhere. I just don't know how to find it right now. Actually, you can probably find it by going inside the clean files itself, but with this Discord streaming, I guess I won't be able to show you that. Yeah, next time I'm going to YouTube. All right. Let's see. If that's done, I'm going to go over some listings. I think that might help some people. Probably. I think people need lists. Okay. So I'm going to go over some list stuff. The not function. Someone wants me to explain the not function. The not function is fairly simple. If you have true, so if I have start equals not true, this will give me false. This will give me a false. It's like flipping the switch, the logical switch. If you have anything that returns a boolean, you can do something like what's something I can say? Let's say 2 is equal to 2, or 3 is 3 is bigger than 100. And then so I'm just gonna put this in parentheses. So let's do something silly like this, and 5 greater than 89, and then we want to put not on top of all of this, so we'll go not. So these are all logical functions, and here we would just, if you get something like this on a test, well, basically you just evaluate this step by step. So you go like, okay, 2 is equal to 2. Well, that's a true. And then we have true, or 3 is greater than 10, 100, that's false. Okay, so that will evaluate into true because it's an or. And then we add that to, well, this one's a false, so then the entire thing here becomes a false. But we have a not in front of it, so we can say we have a not false, which means that this entire thing becomes a true. But this is actually logic versus being functional. So if you want to learn logic, well, you will have an entire class about logic, but yeah. I'm going to go over, let's go over some list stuff. Let me see if there's any interesting list stuff I have. Sure. Okay, so let me clean repro. Let's go to consultation stream, stick in here so that we can work on it. Okay. Recursion and lists. Yes, let's use recursion list. No, not new there. Okay, so I'm going to work on this one. So this is what I'm working, this file CW1. This is on my website. It's in the folder called extra classwork, and if you guys need extra practice, you should give these all a try, because these are actually old classworks that I did when I was learning the class. These were from Victoria. X, Y equals not X equal to 1. I'm just gonna answer this here. Yes. Okay, that's simpler. Okay. So here we have, what's this? Okay, so this is one of those classworks. I'm just going to go through this because it's fairly simple and you can see how things work. Let me create a new project, and this will also kind of show you some basics of lists and maybe some recursions. So here, use a recursive function to generate lists with elements from 1 to x, so on and so forth. Okay, so the easy way to do this is given a function x, we can say 1 to x like this. So this is the easy way of doing it with a list constructor. We're saying we're building a list from 1 all the way to x. That's it. That is not what is wanted here. They say we want recursion. Okay, so we're going to have to use recursion. So given the number x, so we know x is a number, and we want to make a list of it. How are we going to do this recursively? So this is going to touch on recursion and list. So how are we going to do this recursive? Keep in mind that whenever we operate with lists and recursion, there's a few things that I said in class I'm going to repeat again. For example, data is immutable and functional. So when you work with lists, you're never modifying an original list, you're always creating a new list. This is actually very important because you'll have some troubles where you're like, why can't I access that list that I just modified? Well, because it's somewhere else, it's not here. Additionally, when it comes to recursion, and I'll mention this again, you have to keep in mind the tenets of recursion. So with recursion, I'm going to write this here. Recursion is recursive. Yay. So what do you need for recursion? You always have a repeated action. So what's repeated? And you also need a stop condition. Okay. So those are the two things you definitely need for this. So in this case, this is a very simple recursion. What's our repeated action? We're adding elements to a list. So you want to try to keep, when you're doing recursion and you're trying to figure out what you want to do repeatedly, or like let's say you have some really crazy thing, try to break the problem down into very, very simple steps. I know, so here the problem is saying add element to a list from 1 to x. Yes, we have the parameters 1 to x, but let's break it down even simpler. This actual step is adding elements to a list. So that is the actual bare bones basic repeated action that we're doing. From there, we need a stop condition too. Now this is where you can also put some of the others. So we know we need to generate a list from elements 1 to x. So stop condition, when we add enough elements. I'm just making this very vague because really sometimes that's how it works in the tests or real life. You don't actually know a very specific stop condition, but you'll figure it out as you go. So here we have basically our blueprint for our recursion. We know that our repeated action is we need to add elements to a list, and our stop condition is when we add enough elements. And this is important because now we know what we have to do. We need to add elements to a list. Okay? So how do we add elements to a list? And I tell people this when they're freaking out on a test. If something seems big and ugly, break it down into smaller problems and try to tackle a simple small problem first and then make it bigger. So first off, how do we add elements to a list? So we can do, let's say I have a list of 1, 2, 3, 4, 1, 2, 3. If I want to add an element, let's say to the end of the list, let's say I want to add a 4. I can add it by doing this. This will give me 1, 2, 3, 4. Oops. 4, sorry. So that's one way to add an element to a list. What's one thing to note here? The plus plus operator works between two lists. Meaning here, if you have two lists, it'll work perfectly. But here, we're trying to add a single element. What's a common mistake? Is that someone tries to add a single element. So sometimes people will try to do something like this. Like this. 1, 2, 3 plus plus 4. And this will give you, so here, let me type it correct here versus the incorrect version here. Start equals 1, 2, 3 plus plus 4. Sorry. So now that so this might seem a little silly now that you can see the correct answer, but a lot of people end up doing this in their function and they get an error like the error is like they get some sort of type error where they get like int and int, like they get something like int and int error, or they get something like int and v4 error or something like this. And that's because you're causing a type confusion in the system because this is expecting two lists, and what you've given it is a list and a single element. So this is a very common mistake, and try to avoid that. So this is one way to add elements to a list. You can add elements to a list by just, well, sticking that element into a list and then adding it to the rest of the list. Alternatively, you can also add elements to a list. Let's say you want to add it to the beginning. We can also say, let's say I want to do, let's say I have 2, 3, 4 here as a list. Oh my god. Let's say my list is 2, 3, 4. And I want to add 1 to the front of the list. I can do it using this method. If you don't understand this, I can explain that in more detail. Well, I'll explain more detail later anyways with this stuff. This will also generate 1, 2, 3, 4. 1, 2, 3, 4. One thing to keep in mind here is that this here is a single element. Like that. So additionally, when people use this notation, one very common mistake is people will do something like this. So they want to add to the list of 2, 3, and 4. And what they feed into it is a list, like that. This will also give you a type error. This is a very common type error that people see is like type error v4, v6 or some shit like that. What is it saying? Well, they're saying this, we have a list of everything else, and this is the first element. In here, the first element is an integer, so this should be a list of integers, and we need a list of integers to add on to it. This is saying, well, we have a list of integers, but this is just a list of ints. So it's going to say, well, we have a list of lists of integers, but we're trying to attach on just a list of ints. So that is the problem there. And this, I'm mentioning this because this confuses a lot of people. They're like, why is this not working? And it's a little more obvious here now that I'm doing single elements, but some people, when they write a function, they forget, oh, their function outputs a list, and then they try to attach it to another list in this, using this notation. They're like, why is it not working? And same with this one. Sometimes they'll generate a single element and try to concatenate to a list, and they'll be like, why doesn't it work? So just make sure when you're dealing with lists, you keep in mind be very mindful of what type you're working with, and also, let's say, how nested your lists are. Okay. So we got that out of the way. This is how we add so we'll just say this is adding a single element to a list, the simple case. So this is the simple case of doing that. Okay, cool. So what are we going to do here? Well, we need to do a recursion, and we need to add elements. I'm going to say we're going to add elements to the end of the list, okay? So how do we do that? Well, if we don't want to introduce other variables and stuff, we're gonna start with x, okay? And we're gonna use just x here. So what does that mean? Well, we need to put x into a list because it has to be there. So we know x has to be in the list, but we need everything from x all the way to 1. So we're gonna stick x in the list. And I'm gonna use the concatenation here. Now we want to add everything else to that list too. So what we're going to do, list gen, but we've already added x there, so we don't need to add x, but we can go from x minus 1. So no, this one. So this. Now this already confuses some people, and the question is why? Like why are we doing this list? Why do we put list gen here? Well, here's one way to think about this, and this may work for some of you. If it doesn't work and you already have a different way to intuitively think about this, that's fine. But here's one way to think about this that might work for some people, or when you're confused. Here we have an integer, a list of an integer. So x is an integer, the one we started with, but it doesn't have to be. It could be one of the ones along the way. And list gen itself should output a list of integers. So this has a list of integers. So here's how you can do like a sort of type checking. You're like, okay, we know list gen should output integers, and we're going to concatenate to a list of integers. So this one has a single element, x, and this one is going to have, well, in our case, we hope this one should contain everything else. So I'm just going to write this here. This, we're hoping, should contain x. And this, oh my god, this should contain everything else, like this. Okay, I don't have enough space for that. So this should contain everything else, and this should contain just x. Okay, so when we look at this, we're like, okay, cool. So if we try thinking, okay, so this will create a list of x. This should create an entirely new list starting at x minus 1. So we're going to think, okay, so let's say I'm gonna think in my head. Let's say I'm gonna start with a simple case 5. Okay, so in this case we're gonna say, well, we can just look at this and we'd be like, okay, so this, well, this would take just 5 and stick it in there, and this will be the function called with for. Okay, so then what does this for do? Well, the for will do something similar to this. So yes, okay, well, this gen 4, we know it should do something similar. So it should put our 4 into a small list and then call list gen with 3, like that. No, list gen is not a built-in function. Someone's asking, is list gen a built-in function? No, it's not. This is a function we're building ourselves. Yeah, it's just a name. Thank you. So in your head, you should be thinking, well, how would this add up all the stuff? Well, we're taking X, we're putting it into a list, and we need to concatenate to something else here, which is hopefully all of the other elements. Now we think, what would this come out to? So if we took 5, this will put a 5 here, and then this will give us list gen 4, which then should, well, what will list gen 4 do? It will put 4 at the end, and then we think, well, list gen 3, what will 3 do? Well, this will give us a 3, and there should be list gen 2, so on and so forth, like that. So as you can see, we're making a 5, which would then, so there's a 5 here, which would then be concatenated to a 4, which would then be concatenated to 3, and as you can see, this keeps going on. So that's one way to think about this. Now one thing to keep in mind is that this is pretty good. Now we have to keep in mind, okay, so for every time we do recursion, when you have a repeated action, you have to have a stop condition. So basically, hey, when do we stop? So the stop condition, we're going to say, well, we need to stop when x is equal to 1. Okay, so we're going to say, we're gonna take this, put in a new line, and we're gonna do like an if then else statement. So we're gonna say if x is equal to 1. So we're gonna give a condition that will give either a true or false. So this will return a true or false. If this returns true, well, what do we want to do? Well, if x is equal to 1, we do want to include that in the list. We just want it to stop there. So we're gonna stop at 1. Okay, so this is just gonna be a little list of 1, and we could test that ourselves here. We could test that logic. We're gonna say, okay, so continuing from 5 here, well, we have a list gen 2. This should give us, well, we should put 2 in a little box by itself, and then we will have a list gen 1 here. And now we can look at this where, okay, if we give it a 1, it'll check into this condition. This will return true and give us a little box 1. So we'll say list gen 1. Well, it will stop the recursion because it'll stick 1 in a box, but then it won't call itself again. Now from here, you could start substituting things in. So you know 1 is now here. So 1 will get concatenated to 2, which will give us 1, 2, which then is here because it's equal to list gen 2. So this is list gen 1, which is here, gets concatenated to 2, which is list gen 2. So list gen 2 is now 1, and you know what, I'll just write it down. So we know that list gen 1 is just 1. We know list gen 2 is now 1, 2 because we took 1, concatenated to 2, and we got list gen 2. So then list gen 2 is here is 1 and 2, which is then now going to be concatenated to 3. So we're going to have 1, 2, and a 3. And that's going to be equal to list gen 3, which then gets stuck here. So 1, 2, 3 is now here, and now we're going to concatenate a 4. So we're going to say, oh, there's a 4 there. With the repeat, this is now list gen 4, which gets sent here. So in that case, we're going to say we have 1, 2, 3, 4, and we concatenate a 5. So 5. And we're happy. So we found a way to recursively generate a list from 1 to 10, or x, whatever x is. Okay, so does that make sense to everyone? So just to sort of reiterate what I've done so far, what I did so far was I looked at the problem. This is a simple problem, but the steps to tackle it, and sometimes more than knowing the syntax and whatever, is knowing how to think about a problem, which is way more important than honestly trying to solve it. Is knowing how to think about it first, because so that you know how to solve it. So we go, okay, using a recursive function generate a list from 1 to x, blah, x parameter, blah. So we need to use recursion. So we know first we need to use recursion. So we think recursion, we need a repeated action. What's our repeated action? Generate a list from elements from 1 to x. Generate a list. We can generate a list using adding elements to a list. So we add little things into a list to generate the list. So our repeated action would be adding elements to a list. And then we say, okay, cool. Now we need to make a stop condition, which is when we add enough elements, because we just only need from 1 to x. Cool. So we've tackled the recursion part of this problem. Now we have to tackle each of these parts individually. So we say add elements to a list. Now if you can't figure out how to add elements to a list, and for adding elements to a list, it's simple. But sometimes you have something more complicated, like, oh, do this and flip this around and do whatnot. Sometimes the base action is a little more complicated. So in this case, our base action is adding elements to a list. If you can't figure that out for the big complicated thing, just do it for a simple thing. So we go, okay, let's first figure out how to add elements to a list. In this case, let's just do this. Okay, this adds element to a list, or we can add it using this, whatever. So now that we figure it out, how this is how we want to add elements to a list, we say, okay, cool, we're going to make a recursion on that. So first I made list gen x, and then I didn't even write this thing here. I did not write the stop condition. I actually just went straight ahead and did the repeated action. So I completely ignored the stop condition. I just went and wrote this repeated action. I made sure that this works first. Okay. So I went, okay, blah, 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 blah. Does this work? Cool. Now, from here, if we didn't do the stop condition, we end up at this step, and then we go here, and then we go, okay, list gen 0. And then, like, if we didn't write the stop condition, we would very soon realize that, hey, there's a little problem here. So we're going to go, okay, well, at list gen 1, we should probably not let it go to 0 because we don't want to add 0 to the list. So we then make, okay, this will be our stop condition. And if you notice, the stop condition here is very specific. When x is equal to 1, and then we give it a... But my actual stop condition that I started with at the very beginning, and yes, I know how to write this problem, but even then, my stop condition at the very beginning is very like not specific. It's very general. I'm like, when we add enough elements. And this is actually very important, is that when you're thinking about these problems, don't fuss too much about... When you first think about the problem, don't fuss a lot about how the specifics of how you implement it, but think about the big picture of what you are trying to do. So my big picture is adding elements to a list. Now, if I want to figure out specifics, yeah, there's more than one little specific way to do it, but our overall, what we're trying to do, the individual base repeated action, we just need to know that. Same with the stop condition, when we add enough elements. And this is even more important, because if you're too focused on one stop condition, that it might not be the right stop condition, or there might be a better stop condition. But here I just wrote when we add enough elements, and as we're going along, now I see, oh, hey, now I can see exactly, oh, I see that I need my stop condition at 1. Sometimes you'll see, oh, I need my stop condition at 0 or whatever. So this is a very generalized like stop condition, but then we make it more specific later on. And this is our function. Now, that said, like on the test, usually so here it says start equals list gen 10, and this will probably have, on the test, on the homework, it'll be like, we'll give you a sample output, so this will probably have a sample output of something like this, okay? Whoops. But we'll also usually, what we'll do is we'll give you edge cases. So edge cases are cases that are on the edge of what's acceptable, and we'll also give you error cases sometimes to deal with, but mostly it's just edge cases. So what are edge cases? Well, list gen of 0. Well, we wanted list of elements from 1 to x, so this should give you an empty case, an empty list, and we'll also write something like start equals list gen of negative number, and again, this should give you an empty case. So in that case, and as I tell you, start with the easy cases first. Like this is an easy case, list gen of 10. Maybe there might be an even easier case like list gen of 2 or something. But when you have other problems, there will usually be some sample input that's slightly easier and then something that's a lot more complicated. Try to tackle and at least be able to handle the simple ones and then handle the complicated ones and then try to manage the edge cases. Okay, now if you can do all of those at the same time, that's great. But if you can't and you need some sort of step-by-step or to practice and work your way up, try doing this way. Start with the simple cases, work to the complicated cases, then work on the edge case. So we handled this case, and it's not really simple or whatever. But now let's handle the edge cases. So we look at, well, list gen of 0 should give us empty list. Well, okay, let's write in another thing. So x is equal to 0 should give us an empty list. Okay. Now, then we look, oh shit, we need to handle this negative case. Okay, we'll change this to less than or equal to 0. And that's, in a nutshell, how you would solve problems. So you have a problem, and step by step you figure out the solution, and then you just code it in. And really, actually, this sort of method of tackling the problem, I've been showing you syntax, but one thing that also you might not realize is a lot of this class isn't actually just functional, but it's just programming in general. So this is just also how to think about programming. Because everything I write here, I can totally write in C++ just fine, or vice versa. You can write something in C++, you can write it back into functional. Any questions about list gen or anything I've said in the last 30 minutes or so? Yeah, no. You can write your question in one line. You don't have to like split it up. How does a computer know that something is a list? Okay. So the question is, okay, so let me just grab this question and throw it into things so that people can read this here. So what was the question? The question in a little bit too many lines is, how does the compiler know that something is a list? Okay, no, I'm just messing with you. But the way the compiler knows that something is a list, and the way that any compiler knows that anything is anything, really, is there are a certain set of rules. So you need to know what these rules are for whatever it is, okay? So some things will have certain set of rules. For example, how does clean know something is a list? When it's in between these two things. So when it's in between those two, it's a list. Now, what's inside here, they should all be the same type. They should hopefully all make sense and whatnot. If not, then the compiler will scream at you and be like, hey, this doesn't work. But that's how they know, that's how it knows, hey, this should be a list. And it's the same for, well, any language. So when you're working with languages, just make sure you know what's the syntax that lets the compiler know what is what. And if you have problems with these, or you do something, you mess something up, that's when you get a compiler error. So I know some people were confused, when do we get compiler error versus when do we get runtime? It's hard to just say a definite, simple answer to that, but this is one of those cases that will be a compiler error if you mess it up. Okay, I see what you mean. Okay. So an extension to his question is, but listgen doesn't have the list thing. Yeah, actually, yeah, that's true. Listgen completely doesn't have it. So let's go to listgen. So we say listgen blah. Well, yeah, listgen doesn't have a list. So normally it'd be like, what is listgen? That's what this is for, actually. So this is a type definition. It's saying that listgen here is a function that would take an integer and it will give a list, meaning it has an input here. So the input into listgen is one single integer, and the type of listgen, so the return type, but more important, just the type of listgen, is a list of integers. So that's how you say it. Now, there are some people who leave this. We write these in for you just so it's sort of a guide to help get you started and let you understand, oh, maybe you should, here's a hint how you should maybe try to write the program. But it's not necessarily just a hint. Sometimes you have specific interface functions, like you can only ask the user for one parameter, but maybe you need to use 10 of them, something like that. But if you leave this out, so if I just comment this out, how does it know that listgen is a list? So people say, well, let's say I comment out, the function still runs. How does it know it's a list? Well, in this case, you're telling the compiler, hey, you can figure this out on your own. And the compiler goes, okay, I'll figure this out on my own. So the compiler will read listgen. Listgen X. What does listgen do? Here it returns, a list. And then look, it'll be like, well, this is an empty list. I don't know what type this is. Okay, I don't know what the type of this list should be, because this is, I can guess that X, it's going to say, well, I don't know what type X should be because we didn't define it. It's going to look here. X is being compared to a Boolean, compared to an integer. Okay, so so X is most likely going to be an integer. Cool, so we know that this is an integer. It's going to give us a list, an empty list. I don't know what this is. This could be a Boolean. We could be asking, is this true? This could be a real number. We don't know what this is. Okay, so it's going to keep reading. La-di-da-di-da-di-da. X is probably an integer. Okay, that's cool. Okay, cool. Now, if at this point it deduced that this was supposed to be an integer and suddenly you try to compare it to 1.0, it's going to, your compiler is just going to stop there and be like, hey, buddy, what's going on here? But, everything's good. All right, cool. Then we look here. Oh, look, our list now has a type. It's going to look and see, we have a list and it's of type integer. So now it's deduced without you telling it. It's going to be like, oh, X should have been an integer. And in this case, listgen should be a list of integers. And in this case, because this function is not done, it's going to keep on going. This one, it's going to call itself, so it can't really get much information, but it's going to be like plus plus in a list of X. And we know X, we already deduced that the type of X is integer, so this is a list of integers. And this is an operation between two lists of the same type. So whatever this line should give us, if it's a valid line, it should give us a list of integers. So in that case, that's how we deduce that, listgen is a list of integers and X is an integer. And in the case that we're grading your homework, or not even when we're grading your homework, but when you're doing something, you're working in industry, or you actually have a job and you're actually dealing with code, and you have to figure out, you see code and it isn't specified what the type is, or you're not sure because the code is extremely long. This is basically how you would figure it out. You would just go down you basically process it and go, what does this do? What is this? Oh, it's that type, and that, and so on and so forth. So that's how Clean figures it out, and basically how you would figure it out. Okay, does that answer your question? I hope it does. Anyways, okay, so let's see. Let's save this. I think that answered the guy's question. Compute the sum of each sublist. Ooh, let's do this one. Okay. Now someone has a question. I'm gonna wait a little bit. No question? Oh, they'll type it out. Alright, anyways, I'm going over this one. Compute the sum of each sublist. So we're trying to compute the sum of each sublist. Okay, cool. So how are we going to do this? Now, there are some actually pretty simple ways to do this that fortunately you guys have not learned yet, so I can't show you the nice easy way. So we're gonna have to do it a little more painfully, but not horribly painfully. So let's first figure out, how do we compute? So we need to compute the sum of each sublist. So we have some more things to tackle. We know that we have to compute the sum of this list here, but now you have a list, you have a bunch of lists inside one bigger list, and now we have to handle this, and we need to figure out what's going on. Okay, so first let's not even worry about okay, someone said we use map, right? Yes, you would use map. So for those of you who know map, you can use map. I'm not going to go over map yet, just because we haven't gotten to that in practice. We haven't gotten to practice, and I don't think it's been gone over in lecture. But if it's been gone over in lecture, or if you know it already, go ahead and use it. Yes, map would be the easiest ways. List constructor would be even easier, but yeah, okay. Anyways, so let's go over this without map. And with the same thing, we're going to compute the sum of each sublist. So we're going to ask ourselves, well, how do we compute? Well, let's just say, how do we compute the sum of each list? And let's deal with each list here. How do we add all of that? We know that's the action we definitely want to do. So we're going to say, how do we add up a list? Now, if you guys want, we can go about and try to define our own function to add up a list. Now, on the other hand, when you're doing your test or you're on your homework, you're not going to have time to figure that out. It's going to, even if it's really quick, you're still wasting time. Don't do that. Just look up your list function. So I'll say, I'm going to type in head here, highlight it, Control L. Oh, hey, we have list functions. Let's go down a little bit. Oh, hey, there's this very convenient function. What does it say? When addition is defined on list elements, so when you can add the things inside of a list, so sum, when you take a list of any type, it gives you a single of that type, given that you can add and you can have a 0 on that list. Oh, and it specifies that it has to be integers and reals. So basically, you can sum up list elements using a very handy function. Why, thank you. That's really helpful. So how do we sum up a list? Sum list. So if we do start equals sum of 1, 2, 3, 4, this should give us the sum of 1, 2, 3, and 4, which is 10. I can do math. So cool. We've summed up a single list. We don't have to redefine it. Let's sum up each and every one of these. Okay, cool. So how do we do that? Well, we don't know how many sublists we have because it can be one of them. It could be a whole bunch of them. That's cool. And what is he typing? Oh, someone's asking. So here, sum of a list is a predefined function. Yes, sum is predefined in this case. So and that's why this one is called sums. I still think that's a bad name, but you know, you don't want to call it the same name. I'm gonna call it something else. La 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 la. We're gonna call our function la 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 so that it completely is different. Alright. So we're gonna have this function here called la 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 la. I'm gonna take in a big list. I'm just gonna call my variable big list. Why? Doesn't matter, but I just call it big list so I can keep track that this is the overall big list. Okay. And what am I gonna do? Well, I'm going to do some recursion. So in a recursion, what do we have? We have a repeated action, and I'm going to have a stop condition. I know this is going to sound repetitive, repeated action, stop condition, but when you do any recursion, you're going to have a repeated action and a stop condition. And when they ask you in an interview, what is recursion? How do you define it? Recursion is a repeated action and a stop condition. Yeah. Okay. So what's a repeated action here? Well, repeated action. We actually have to recursively do two things. So we have to sum sublist, add it to big list. Okay, so we sum up a sublist, we add it to a big list. Okay, so now we have to consider some typing things here. Okay, so this here is a list. This here is a list of stuff. In this case, list of integers. So when we sum it up like this, well, when we do the simple step, what do we get out? An integer. So we have to keep this in mind. We have to keep this in mind that our result is going to be a single integer. So how are we going to do this? Let's try, I'm just going to go back up here. How do we add an element to a list? We could do this. I'm going to try using this one, just because. Why? Because we're going from the front anyway. So what are we going to do? I'm going to say big list here. I'm going to take the head of big list. So head, for those of you who don't know, is the first element. So we're going to take the first sublist. And we already know to sum things up. Just use sum. Okay. So we have the sum of a big list. Now, first off, what is this type? It's an integer. Cool. So here's a common mistake. Someone does this, and then we say we're gonna do recursion on tail of big list. So this is a very common mistake, and people are like, why am I getting a compiler error? Well, of course you're gonna get a compile error, you silly. What does sum return? Well, okay, I don't know what sum returns. Let's say I'm really stupid. What? You got a green screen instead of the live stream? I swear I don't have a green screen in my room. My flat is not that big. Anyways, so people are like, why does this give me a compare? Well, of course it's gonna give you a compare, but let's say we don't know why. Let's see what sum gives us. Sum gives us, oh, a single element here. And let's say we don't even know what the plus plus should do. Okay, well, let's click here. Plus plus should take a list and a list, and it gives us a list. Okay, so why are we getting compiler error? Well, sum here gives us an integer, and this gives us a list. This requires two lists. Oh, so that's why we're getting an error. So in that case, how do we fix this error? Well, we just stick this single element into a list. Now, if I don't want to do that, and this is using the concatenation, but I'm going to do it with this one. So in this one, it's actually okay that's a single element. We just stick in a list where we go single element, colon, and everything else. Okay, so I'm going to do that. I'm going to do, let's try it using that method. So we don't close off this list. We put a colon here, and we go here. Now we have to just check the types to make sure it works. The guy says we use that to divide the list. Oh, this is a very good question. So I'm going to copy this on screen. Here. So the question is this. So we use colon to divide it to connect them. No, you don't actually. Colon doesn't. So we can use colon to divide a list, and we can use colon to build a list, which I guess is confusing because you're like, what the fuck? How are we dividing and building the list with one operator that's supposed to only do one thing and only have one output? That's because we're not actually. It's not an operator that actually does one thing. It's a pattern matching. So let me clarify. So we have 1, 2, 3, 4, 5. Let's say we pattern match this into A colon B. Okay. What does this mean? Well, it's gonna take one. We know we need a single element one. So it's gonna go okay. A 1 is matched into A, and then this colon. It's not an operator actually. It doesn't divide or put things together. What this is just saying is that everything else is going to be stuck into B. So everything else, so we used up 1, everything else is now B. Okay? So I hope that sort of clarifies what that does. So in kind, we can actually do like 1, 2, 3, 4, 5 and feed it, pattern match it into A, B, C, colon, D, like this, okay? And in this case, well, what's going to happen? It's going to pattern match. So A, where's A? A is going to be 1. Cool. B, what's B? Well, in this case, B is a single element. Okay, we're going to take 2. Let's look, next one. C, well, C is still a single element. So it's going to be 3. And then now we hit the colon. So the colon is going to be like, oh, now we want everything else. Well, so D is now going to be, well, what's everything else? 4 and 5. Okay, so this is pattern matching. So it's not necessarily first and everything else, or it can be a couple elements and then everything else. And then, so this guy types, oh, so if we type this, we get that. And I'm going to address that. That's another actually common error. Boink. I'm going to break this up into 2 lines. And I'm going to move this back. So if we type this, for example, you're going to get that. No, actually, you're going to get a compile error. And now you're probably thinking, wait, why? Why are we going to get a compile error? What's the type? What is the type of this? What is the type of this? The type is a list of integers, meaning that this list should be a list of lists of integers. And everything else, each of them is just an integer. So you're going to actually get a compile error of that. So notice here, we and let me actually explain. This will be more clear once I finish this pattern matching, but going the opposite way. So when we go the opposite way, you kind of see what happens. So you can use the colon to kind of break up something, pattern match and break up something, but you can also use it to put it back together. So let's say I have 1 colon 2, 3, 4, 5 like this. Okay, so what is this? What is this doing? This is going to be using the pattern matching. So here we had this pattern matching that said there's this first element and everything else. Okay, so what is this going to do? This is going to say we're gonna make a list. Cool. And we're gonna have the element 1 in there. Cool. Oh, and we have a list of everything else. Okay. So what's everything else? We're gonna read it from there. It's 2, 3, 4, 5. Cool. So if you look at this line here, it's pretty much the opposite of what this line is. So our A was a 1 single element, no list, and our everything else is a list of everything else. But when we extract those back out, they're single elements. So what does that mean? Well, let's try the other one. What if we do 1, 2, 3, colon 4, 5, like that? So what would this give us? Well, this will give us, well, it's gonna say we have a list. Cool. It has elements 1, it has elements 2, it has elements 3. Oh, and we have everything else. Okay, let's just put everything else in there. Okay, cool. So in response to that question, so it's the guy. So the question is, in every list, the head is always a single element. Okay, head is not a list of elements. It's not even a bunch of elements. Head is always specifically head is just one element, the first element, and tail is always the last element. Okay. What's important is that what's important is that this pattern matching isn't matching head or tail. This is matching element, 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 rest of the elements. So here we have one element, we have element, rest of the elements. Hence, that's why this operates as head. So this was element, rest of the elements. Well, this was element, 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 rest of the elements. So it was 1, 2, 3, rest of the elements. So then when we reconstruct it, it was element, rest of the elements versus element, 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 rest of the elements. And it seems weird, but the reason why you do this is so that you can do, let's say I want to build a list, but I don't know what the rest of the elements is, then this is colon function that returns rest of elements. So in this case, we know what the first three elements are. We go say 1, 2, and 3. And then we know we're going to have something that gets the rest of the elements, but we don't know what they are. So we're just going to put here colon and just say attach. We're going to give you a list of all the other elements. So you just stick them on to the end. Basically, that's what it's doing. Which is why this won't work. Because here it says a list with one element, a list of lists. And then you're trying to attach it to the rest of the elements, of which each element is just a single number. So this is why this is going to be a compiler. Okay, so I hope this kind of helps clear that out. If you guys still have questions regarding this colon thing, you could definitely ask. But I hope this helps a lot. And just keep in mind, this is what's called pattern matching. And pattern matching, I haven't been using the term as much in the beginning because it's going to just confuse you even more. But you're going to hear it more and more from now on, just because literally everything in functional is pattern matching. So, and it's the shrink of functional, so you're gonna need to get used to it also. Okay, so what did we do here? We basically did the same thing as we did up here. So we have a single element, a single number, and we're attaching it to, well, we don't know what the other numbers are gonna be, so we don't know what these other sums are, but we're just gonna say we're gonna attach it to a function that will give us a list of these other elements. And we know that la will give us a list of these elements because we said it will give us a list of these other elements. So yeah, that's good, that's fine. Okay, so that's cool. So we know that it'll go here. It'll take out the first one, take out the first element, which is a sublist, sum it up, put it in the new list, and then we're going to keep going with the rest of them. Sorry about that, M4XI. If it's any consolation, I will put all of this back on YouTube later. Okay, so yeah, I know that streaming is not the best here, and I didn't know that it was limited to 10, and there's a lot of technical issues. I'm just gonna throw this entire thing on YouTube and my website, so you can watch all of it in complete glorious detail later, and hopefully that will be good. Okay. Actually, I hope the recording doesn't have all of these weird things to it. Right, anyways. Okay, so sum up a big. Okay, so we have this here. Now we need a stop condition. So what is our stop condition? Well, our stop condition, I'm just gonna keep it general as always, is, well, how do we stop? Well, when we have added all the sums of the sublists. So when we have gone through all the sublists and we added all of them, we should probably stop. So in that case, we need to put in a stop condition here. Well, how do we know when to stop? Well, we need to say, well, let's say we're going through each of these and we're adding them here. And then it's going to need to take the tail of them. So it's going to take the head. So let's say we get down to the single element. It's going to take the head, which will be one of the lists. And then tail is then going to become an empty list. So we're going to say, okay, so our stop condition is going to be, well, when it's an empty list. So actually, I'm not going to do it with this. I'm just going to do it with the if then. So we need to put in a stop condition. So we're going to say, well, if our big list is empty, and this empty is a predefined function, you can write it yourself, but it's predefined. So if it's empty, well, we shouldn't concatenate anything else. So we'll just put in an empty list. That'll stop the recursion. Okay. So this is basically most of the problem, except we do also have to keep some things in mind. So what are some things in mind we have to keep? We see here that there's an empty list here, and then when we sum it, it has to give a 0 back. Now if we run sum on an empty list, it's not going to give us a 0. It's going to just, actually I don't know what that gives us. Let me just give it a check. Start equals sum of empty list. Uh-oh. Big list undefined. It has a problem with these capital letters. Okay, let's make big list slightly less big. Start row cannot be overloaded. Where's the other start row? Cannot be overloaded. Yeah, so I can't sum on an empty list. It's gonna give us a problem. No, big list is not a predefined function. Apparently, I guess New Clean made a thing so that you can't have capital letter variables. So I don't know. It seems to be a problem now. It didn't used to be a problem. Anyway, so you can't sum on an empty list. So we don't want to let it sum on an empty list. In fact, we don't want it to even reach this part, because if you take a head of empty list, it's gonna get confused. So what is it? So if we have an empty, if our sublist, so what's important is that if our head of the big list, so if that is an empty list, we need to stop it. We need to stop it before it gets to this point. So we need to add another condition. So we're just gonna say, first off, we checked if it's empty. If the big list is empty, then we do this. Now we do if HD of big list, if this is an empty list, so I can either do equal empty list, but it's more consistent to say is empty. So if this is empty, we're going to, well, what are we going to do? Well, we need to give it a 0, but we can't just do this. This is actually a mistake. Why? Why is this a mistake? Because if we just put in a 0 like this, or we just give it a 0, so some people do that, that's a mistake. Why? Because we're returning a 0 when we're expecting an integer. We want to add this 0 to a list. Well, then some people say, okay, we'll do this. That's also a mistake, because then yes, it will work, but then in the end you're just gonna get 0 whenever you have an empty list. The problem is that you actually want to continue the recursion. You don't want to stop it here. So you actually have to continue the recursion, and we don't even have to think about that. Just go like this. Boink. So that's how you would continue the recursion. And this is basically the answer to this question. Now, for those of you, if you guys have any questions, please ask right now. But if not, I'm gonna just keep writing more. So there's an alternative way to do this. So la 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 2, given there's many different ways to do this. So let's say la 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 2 big list. For those of you who know map, we can do map sum big list like that. That's one way you can do that. So you're saying that we'll go over this in class. But we're basically saying that we're making a new list where we summed up each sublist there. That works too. We're gonna also touch on later. We're gonna touch later on function comprehension, and this is probably the easiest way to do it. Actually, the easiest way to do a lot of things. You make a list symbol. You put this in the middle, and we say x big list sum x. So that's another way to do it. As you can see, when you really master functional, it's that this is where the real strength of functional is, and where functional really shines, because you can see, oh, nice, look, where suddenly we can write things that takes in, like, even in this, when it is recursive call, took quite a few lines, and God forbid you want to do this in C++, it's gonna take a lot more lines. Actually, I can probably write in C++ just to try. But anyways, basically, if you had to write this in C++, it takes a lot more lines. Actually, I'm just good. And I'm not going to write C++. I can't think C++ right now, not that I don't think functional. But this is going to take a lot more lines than C++. So you can see that you could take something that would take a bunch of lines and just write it in one line. That's the charm of functional. That's why I always say functional is a lazy language for lazy people like me. Because I am a lazy person. Okay, any questions? I'm already nearing the 2 hour mark. Okay, I'm going to end at 2 hours so that I don't kill myself, but I'm going to go over this problem first before I end. If you guys have any questions, please definitely type them in, or I don't think I muted that many people, but if you want to ask it on mic, just let me know so I can turn on your mic and listen to you. All right, so number 3 here. Insert X as the first element in every sublist of a list. So if the sublist was empty, then X would become the only element in the new sublist. So this we also have something that's pretty clear. We need to insert X as the first element in every sublist of a list, and then we have to do it for each of them, and then there's a slight requirement here. So we can worry about this other requirement later, but first we have to be able to insert X as the first element in every sublist of a list. So let's try tackling this problem, and let's try it with a simple case first. So we can do start equals, well, let's say we want to add an element 1, and we want to add it to 2, 3, 4, 5. Okay, so how are we going to add that in? Well, actually, we already kind of did that. We could do that. We could just say we have a list of things, and we're just gonna that will add it to all of them. I mean, we already showed that we can add it as a first element like that, or we can also say we can do stick 1 in its own little list and then add it to 2, 3, 4, 5 like that. Or you can also say start equals, oh my god, there's a very special function called insert@, where you can tell it which position you want to put the element you want to put in the list, and you could tell it to put it there. So I could say I want to put an insert at the 0 position on the number 1 into this list of 2, 3, 4, 5. Now this last line here seems the longest, seems the craziest, but this one actually is the most useful one, just because here you can specify, oh, I want it at the 0 position, but let's say we tell you to, hey, add the function in the middle, and you're like, oh shit, now I have to add it in the middle. So and actually I'm just going to show you how to do that. So let's say we want to add a function, insert at somewhere. We're going to insert 999 into this big list like that. But how do we get this middle? Well, in the case that you don't know the size of this list, you could just say length of our list, so which is 12, 3, 4, 5, 6, 7, 87. But later on you'll end up with variables anyways. Length of this divided by 2. So now we can get, this is how you would insert something into the middle. So this is the insert at is very useful. Actually, built-in functions are all very useful. Anyways, so now we've figured out, okay, how do we insert x as every element into the sublist? Now we have to do it to each and every one of them. Cool. And as before, if you know map, then this is trivial. If you don't know map, then we can do it with recursion. So there's a couple ways to do it. So but let's say, so this takes a big list and a function. So we're gonna say big list, and we're gonna say insert me. Okay, so we're gonna do that. Okay, so how are we gonna do this? Well, we know for the first element of the list, so we're gonna take the first element of, so for the first element of this big list, we're gonna say hd of big list. So this here should be the first sublist. Okay, cool. So we have a sublist, and we want to put that element before it. So just as before, we know that this here is a list, and we want to put an element before it. Okay, so we go do insert me colon, and just stick little things around it. Okay, cool. We have a list here. Cool. We have a list here we have a list here that should have, we have a this would have been this list, and we just now added to front of that. But now we have to tack it onto everything else. So we're just gonna do that recursive. So again, we're gonna do this and everything else. Everything else. Well, what is everything else? Well, everything else is insert x on, well, we already did it with the first element big list, so we're just gonna do it with the last however many elements of big list. Oh, and also insert me. I forgot. There we go. So the element that we insert doesn't change, but we just do it with the last element of the big list. Need to fix my parentheses. There we go. Okay. Now that said, just because insert me here doesn't change, it can change. So let's say we wanted you to insert 1 and then 2 and then 3 and then 4 and then 5 and then 6 and then 7, or maybe we wanted to insert Fibonacci numbers if we wanted to be extra tricky with you guys. Then insert me will have to change, but you can take that step by step. So now you know how to insert a single element that doesn't change, and then you can slowly change insert me, but worry about it step by step. But anyways, here we're just inserting a single element, so this will basically do it. Now with every recursion, we did the repeated step. So we take the big list, we insert this element in front of it, and now we do it with the rest of it. Cool. Well, we have to stop when we, well, basically run out of sublists. So we say, well, insert x, well, when we encounter an empty list, and I'm gonna start using this notation. So when we encounter an empty list, and in this case we don't care what the last thing is, then we're just gonna stop it there. So this is a very common way to stop list recursion. Given an empty list and you don't care about anything else, you just give an empty list. Yep, this is pretty common. Now this is not, we're not using an if then else statement here because this is a pattern matching. Now this has to go above because it has to, if we have an empty list, we wanted to hit this and match this first before it reaches here. So it's almost like the if then statement, but it's a little different. It's based on pattern matching. Now we have to, let's see, what else do we have? If the sublist was empty, then X will be the only element. Let's see. Head of big lists will give us an empty list. Let's say that's an empty list, but then you do this colon empty list. Okay, that's fine. Doesn't matter. In this case, we already handled this case because if it was an empty list, we call it, nope, no problem. We just have that. So there you go. That's a solution. Basically. Now, I mean, now, let's say we wanted to, write this with map or something like that. Now, map, on the other hand, will be a little harder. So this is where map is not going to be quite as easy because map is going to be map. You need to map a function to the big list. Now, what's this function? Now, you can either write the function separately. So if you don't know how to do an inline function, you would have to write it separately and then call it here. But if you know how to do, and we will learn this later, is like given an element. So I'm gonna call this element, or actually given a sublist. So given one of the sublists, what we're gonna do, we're gonna return insert me and the sublist. So this is basically what we're doing, what we were doing as above. So basically given it's gonna take each of them and then each sublist, and then given that sublist, it's gonna basically attach it to the front. Now this is where map isn't necessarily the best. Well, I mean, actually it's not bad, it's just not the smallest. So let me call this 2, I'm gonna call this 3. In this case, list constructors are even better. So how do we do list constructors for this one? I'm going to do, so given a big list, we're gonna extract sublists, and for each sublist, what are we gonna do? We're gonna do insert me colon sublist. But either way, they're still both one-line solutions, and for a lazy person like me, both of them are completely okay. See? So yeah, there we go. You guys will learn this. You guys will learn map. I think you guys already learned it in lecture. If you didn't, well, we'll do it in practice, most likely next week. This is called a lambda statement. You guys will learn that soon, probably. I think you learned this before midterms. Anyways, I don't know. I think you also learned this one before midterms, is list comprehension. So once you learn these, you have all these useful tools which let you take 50 lines of C++ code and boil it all down to one line of code. And also you'll realize that when you encounter this, so let's say you never do functional programming because you guys hate it for whatever reason, that's cool. But then you also realize that when you go somewhere else and you do Python, for example, and you realize, oh hey, they have list comprehension in Python. Oh, they added functional into Python because functional is very useful. And then you do Java and they say, oh, there's list comprehensions here too. Huh. And then you go into, yeah. So basically try to learn these concepts. It's a way of thinking, and then you realize that it's very useful. And even if you don't like functional languages, even a lot of imperative languages now have functional. So have fun. I'm gonna end the stream here just because we've been going for quite a while. But do you guys have any questions before I run off, or I don't want to leave you guys like hanging? Oh, by the way, the version of this that I'm gonna post on YouTube, I don't, I don't know if I'm gonna ask you guys right now, but I'm considering editing it before I put it on YouTube, because if I put it on YouTube with all these like pauses and talks about technical problems, I think it'll bore out people. So maybe I should edit the version I put on YouTube. What do you guys think? I edit the version I put on YouTube and put the whole version on my website, or just put the whole version on YouTube? What is the name of my YouTube account? I don't have one yet. No, seriously, I don't have a YouTube account. I only use YouTube to watch meme videos and cat videos. Okay, fine. I watch things more significant than that, but I don't have one yet. I will make one. It will be on my website, and I will tell Victoria to email it to everyone. Okay, and also, okay, so the one person said, should I learn clean enough to pass the exam or focus in a programmer life? So to answer your question, first off, this class is functional programming. Now, one of the things about this class is originally, when I was taking it, it was a second semester class. So they already expected you guys to know some programming concepts, and then they focused a lot, and that's one of the big changes in class. They're focused a lot on the functional side. Now, the class you guys are taking right now is a first semester class for first years. So what I'm teaching in this class, and a lot of what I do in the class, a lot of what I do in practice, a lot of what the homeworks are geared. The homeworks have all been rewritten, and same with the classworks. But the homework specifically, I rewrite them, and when I write them, they all have these problems that have some sort of application in your programmer life. And when I do practice, there's a lot of things, and you'll hear this a lot. I'll say, oh, this is not just a functional thing. This is a programming thing, or this is something you encounter in every language. So what's the takeaway? In this class, what I want you to take away, if you can learn the concept of functional programming, how to think in functional, I would say try to do that, because functional the way of thinking is really useful for your programmer life, because not just this language, but there are many functional languages that are used for a lot of things. I personally work with Erlang over at Ericsson, and we use that to develop. So Vodafone Greece is one of our big customers, along with Deutsche Telekom, which is in Germany. And so if you're one of those customers and you're trying to use data on your phone, it goes to software that Ericsson and myself we've worked on, and it goes to all this functional shit. So all of this functional stuff handles all that anytime you do a data request. So it is actually used a lot. Facebook Messenger was originally written in functional. WhatsApp is written in functional also, and a lot of things are written in functional. So there's a lot you can do with functional, and it's very powerful. And there's a lot of languages for that. Now, that aside, let's say you don't really care for functional. Okay, so you don't care for functional languages. There are a lot of imperative languages, like I always mentioned, Java, Lisp, Python. Those are some of the big ones, big heavy hitters they're very imperative, but they've incorporated a lot of functional capabilities into themselves, because they found that, hey, if we can incorporate this and let programmers save, instead of writing 50 lines of code, write one line of code, everyone's going to be happy. So basically, that's what they did. And so that's another reason why you want to write. Now, and another thing about that is some people have done research. They noticed that, hey, some of these functional languages, they compile down into C. So why are we learning it? And someone actually asked me a question like, hey, this language compiles down into C. Why are we learning it and not learning C? Well, yes, it does compile down to C. And the reason for that actually is because C, pretty undisputably, is the most efficient language at handling like memory and just being efficient. But by the same token, you can say, well, C compiles down into assembly, which then compiles down into bytecode. So why aren't we coding like the people in the 1960s and doing bytecode or coding like people from the 1970s and doing assembly. Well, for the same reason why we basically, so that's the same reason why we're doing functional. It's horribly yeah, if you're good, you're an expert, you're a genius, you can do assembly, but hell, even I can't do assembly all that great. Most people can't, actually. Most programmers can't do assembly all that great, and there's a very, very small amount of people who can even do bytecode. But so yeah, it's not very effective and efficient to write huge programs in that. That's why we have these higher level languages to do it. And yeah, C is slightly higher level, and functional is even more higher level. But the idea is that if you can write functional, it will make your code, even though it compiles down to C, it will be very efficient. And they've tested this. There's lots of papers. Now, let's say you don't care for functional at all. Functional is not your thing. You hate it. It's not just, it just doesn't make sense to you. That's okay. It really doesn't make it. It's not meant for everyone. Not everyone gets it. Now, in that case, I would say yes, learn clean enough just to pass the class, because ultimately clean is really just used in this class. Clean is a good gateway drug, and I say that and I mean it that way because if you learn clean and its syntax, it makes all the other functional languages very easy to learn. But yes, clean itself is used almost entirely in the academic world. And if you don't care for functional, yeah, you're just going to have to learn it just enough to pass the class. But in that case, I would also tell you, try to pay some attention to this class because this class, I try to teach you guys a lot of programming concepts. So recursion, for example, and you'll encounter trees later. So recursion, trees, manipulation of lists, and certain algorithms, like sorting algorithms, for example. These are just programming concepts in general that even if you don't do them in clean, you will have to do them in some other language. And sure, the syntax will be different, but the way of thinking is still the same. And actually, I focus a lot on how to think. So during the stream, I was saying, oh, you have this problem. Here's how to break it down. Here's how to tackle it. This isn't functional. This is just thinking about the problem in a programmer like way of thinking about a program. So you take a problem in English and you think about, okay, as a programmer, how am I going to tackle this? So that's one big takeaway I want everyone to take away from this class is how to program. Okay, and you can ask some of the tutors who are second years right now. After they took my class, they took the class last year. They went into algorithms and data structures, and they went into imperative with C programming, and they had to do all these things that we covered in functional. And yeah, sure, now they're doing it differently, but since they went over it with me and I tried to explain as well as I could, they're like, oh man, I'm so glad I did it in functional. Now it's super easy. So that's kind of the takeaway. It's like, I want you guys, ultimately, ideally, I want you guys to be, I want you guys to find your love for functional and like it and be able to appreciate what it's good at. But if you can't, I want you guys to at least pass, but take away with some programming experience, because I'm trying to give I'm a third year student. I'm in bachelor, so I'm not like anything special at all, but I'm trying to give you my experience with functional programming. And since I've worked in Erlang at Ericsson, like trying to show you guys, here's how functional and programming can be from someone who's had some industry experience. I want to share that with you guys. So yeah, I hope that answers the question. Oh, and speaking about industry and all that stuff, if you guys, I know this isn't functional related, but if you guys, and this really goes same with all the other tutors, although I know a little more, but if you guys have any questions about programming in general, programming in the other languages, or also if you guys have questions about just like life shit, like, oh, how do I get an internship, or how do I go find a job, or stuff like that, yeah, feel free to ask us, okay? Let's see. He asked, like standard list, but it's gonna take a long time to search. Oh, okay. So how do you search for a function if you don't know the name of it? Okay, so yeah, sure, I'll go over that. I mean, I already kind of went over that, and I go over it in class too. But okay, yeah, I'll cover this, and then I think I'll end anyways. Yeah, I've been going for a while, but I mean, honestly, I don't mind going for a long time. I'm actually just here to try to help you guys. But here, let me go over this. So to get these predefined function lists, you have to memorize. There's a lot of these different files, and they're not all together. there is, okay, you can go to klugo.com, org. This is on my website. This website is on my website. I have this as part of the resources. Klugo.org is basically Google for clean. You go on there, you can Google a function, and you'll find a huge list of them. You can go use it. Now, that said, I will say there's problems with this. Notably, you can't use that on a test. Sorry. You can't use Klugo on the test. In fact, you shouldn't use the internet. I'm sorry. But also another downside to Klugo is that because it contains literally every damn thing in functional, in clean, it might be overwhelming. You try to look up a function, then you see 10,000 functions, and a lot of them are stuff they're useful, but you don't need to know them yet, and they'll just confuse you. So I would say use the definition list there. So how do you find those? Well, first you should probably remember a few things. So here are the ones I memorized. So this is how I should remember. I memorize ABS, and this should give me standard overloaded. I do, let's see, sorry, I'm blanking out right now. I do head, and this will give me standard lists. I don't know. Let me check. List. Okay. So ABS gives me standard overloaded. HT gives me standard lists. There's FST, which will give me standard tuple, I believe. Let me check. Yep. What else? Some is in standard list. Try to think what possibly can give. Let's see where folder is. I think folder is in overloaded, but not maybe. No, folder is in list. Map is in list. Oh, let me see this one. Oh, yeah, here's one. So this is the composition function, and this is in standard functions. Standard functions, yeah, that's what it's called. I think that's mostly it, really. Yeah, there's a whole bunch of them, but no. Yeah, basically this. I guess if you want standard Boolean won't help. So no, basically, I guess this would be your whole list of kind of things to search. So I mean, you can pick one. So I remembered ABS, but you can choose a different one. You don't have to you can choose rem, LCM, whatever, or sine, cosine, tangent. Head is for list, FST is for tuples, O is for functions. And each of these pulls up a different file, but if you just memorize one of them and then go through all of them, and I use lists all the time as an example because lists have so damn many of them. There are so damn many. Like, look at this. There's so long. So fucking long. And the thing is, and to be completely honest, I don't even remember all of them. Like, one thing that I forget a lot is like insert at. I always forget that. I'm like, do I put the number first and then the element, or do I put the element and then the number, or whatever? So I have to come back here all the time. But when you study for the test and stuff, go through this so that you can at least, you don't have to memorize them, but at least you can be like, oh yeah, like I think, I want to put two lists together into one list. Oh, I think there was something in here that does that. Oh, here. There's something. Oh yeah, here. These take two lists and stick them into one list or something like that. So just try to kind of go over these, and well, I'll upload this file onto my website, but yeah, just try to remember these are your favorite one, okay? And yeah, I hope that's good. Yeah, HD. Yeah, that's HD. Okay. Thanks everyone for coming, and yeah, next time I'm gonna try YouTube. I'll make a YouTube channel. I'm so sorry about that. Discord streaming is still new, and I guess I'm so new that I didn't know it. I'll go over that in specific with you later, how to understand those. Actually, I'll probably do that in a separate stream, just because it can get a little weird. But I mean, if you look at it, it's like, oh, it's a list that goes to A. You can kind of, if you already know what the function does, you can kind of figure it out. But if you still can't, I'll do this in another stream. But anyways, yeah, thanks all for coming, and Thanks for being cool. And I don't know, have fun. Have a good day. If you guys have homework problems, feel free to bombard me. Let me know. I'll be around. Yeah. See you around. Bye.